Now that we have our map set up nicely, let's begin building a system that will add entities to our world. We're going to follow the same pattern we used for the map system. We will build a simulation system that models our entities entirely separate from how they might be rendered to the screen. Then we will have our render component read this simulation information in order to produce a visual representation that Unity can display. Let's add an entities game object to our world object that we can use as a parent for all of the entities we add into our scene. Then we'll create a citizens child object that will specifically hold the citizens we create. Now we'll create a new folder called Entities to store all of the simulation logic related to our entities. Inside that folder, we will create another folder called Citizen, where we will begin adding scripts related to the citizen entities. Let's start with a script called Citizen that will represent a single citizen in our simulation. Let's remove the MonoBehavior base class because this is a script related to our simulation, not the Unity rendering. Then place the script into the root namespace and clean up the methods we don't need. We will add a private static int to this class that will keep track of the next ID we have available to label each citizen. This will start at 1 and not 0 for reasons we'll cover a little later. Let's define a public constructor for the class, then we'll define an auto property with a private setter for the citizen's ID value. We want to be able to set the ID in the constructor, and then we don't want any other class to be able to change it later. Now we can set the ID in the constructor using the static int we just set up. We will use the post increment operator so that the current value of the variable is assigned to the ID and then the value is increased by 1. Now we'll import the Unity Mathematics library and define another auto property that will hold the position of our citizen on the world map grid. This property will have a public getter and setter because we want the entity system to be able to move the citizen around the map. To create the next property for our citizen, we are going to introduce a new type into our simulation. We will create an Enum type that is called direction, and it will represent the 8 directions that an entity can move on our map. Let's create this type in the map folder because it is most closely related to the map itself, and then we'll open it in the editor to set up the value. We will mark the type as an enum and then place it into our root namespace and clear out the methods. We are going to use 2-letter abbreviations to label each of the 8 directions. East will be EE and northeast will be NE. You should have 8 total values when you're done. We are now going to define another enum type that we will need to complete the citizen class. We are going to define a nation type with a value for each nation that a citizen can belong to. But let's place this enum in the citizen folder because it is specifically related to the citizens. The process will be identical to what we just did for the direction, but in this case there will be 3 values: guys, Celt, and Taylor. Now let's return to the citizen script and use these new types to finish the list of properties. We are going to define a direction property for the class. It will also be an auto property with a public getter and setter. Just like the position, we want other classes to be able to manage a citizen's direction. And then we will define a nation property in exactly the same way. Now let's introduce a public tick method into our citizen class. Each citizen will have behaviors that are represented by states, and we want a method that allows us to update the logic of these behaviors. This is what we will use the tick method for. It'll be called by the entity system each time it receives a tick event from the simulation manager. Now we're ready to begin building the entity system. Let's create a new script inside the systems folder called Entity System. Then we'll open this script in the editor. Let's place this script into the root namespace and then be sure to set its base class to Simulation System. Let's start by defining a list of citizens that the entity system will keep track of. We will make this a private variable because we want the entity system to be the primary manager of the citizens. Now let's override the init method we defined in the simulation system base class. Remember, we do not need to call the base class methods because they are all empty. Then we will override the tick method, and we can iterate through our list of citizens calling the tick method for each of them every time a tick event is received. And finally, we'll override the quit method from the base class. Now let's go through the process of subscribing the entity system to the tick event. We will introduce a private method called setupEvents again, and then call this method in the init method. We will use setupEvents to subscribe to the tick event from the Simulation Manager class, and then we'll go over to the Simulation Manager class in order to include our new entity system. Before we do that, let's call the setupEvents method in init. Let's introduce a public instance variable for our entity system right below where we define the map system. It will also have a private setter to ensure that only the simulation manager can assign this variable. Then we'll instantiate this variable in the awake method. We'll call the entity system init method in start. And finally, we'll call the quit method in onDisable. This sets up our entity system in the simulation manager exactly like our map system was set up. Let's return to the entity system and make sure to unsubscribe from the tick event in the quit method. And now we have this new simulation system all ready to go. It will now be receiving tick events just like the map system, which then will be passed on to each citizen. In the next video, we'll begin creating our list of citizens for the entity system to manage, and then, just like we did with the map system, we'll begin building a way for the rendering component to display the citizens on the map.